Hello there, and welcome to our lesson on expected value. So expected value is something that companies will use to determine what they should expect based on probabilities. So many times financially is what companies are going to need to budget. So they need to expect what their incomes might be, what their expenses might be, all based on probabilities. So what we're going to do in this lesson is we're going to try and find those expected values. And we're going to start with a few examples. But what I want to start with very first is the fact that we have an expected value computation here. And what's important to note before we get started is that each one, E is going to stand for your expected value. But you're going to have a probability multiplied by some type of value plus another probability times some type of value, and so on and so forth. And then you're going to add those products up to get your expected value. So I'm going to use some highlighters here because I think that they're going to be really helpful. A new flight route. Spirit Airlines is considering adding a route from Pittsburgh to Nashville. Before making a decision, the company needs to consider many factors, including potential profit or loss. After considerable research, Spirit estimates that if it adds the route, there's 60% chance of making an annual $800,000 profit. There's a 10% chance of breaking even and a 30% chance of losing $1 million. So 3 different probabilities happening. We have 60% chance of making an $800,000 profit. So that would be definitely a positive. There's a 10% chance of breaking even. That means 10% chance that nothing changes. And then we've got a 30% chance of losing $1 million in this deal. So 30% chance of losing money, that's going to be a negative. Now, how much can Spirit expect to make annually on this new route? They're going to take all 3 probabilities and consider them together. So the expected value, E, is equal to, we're going to take 60%, that's a probability, times the amount of $800,000. That's a profit, so that would be a plus. Then there's a 10% chance of breaking even, and breaking even means that you don't have a profit or a loss. So that would be 0. Then we're going to have a 30% chance of losing $1 million. So we're going to add that product in, but losing $1 million is multiplying by a negative $1 million. I'm going to use my highlighter again. This first value right here came from the 60% chance of the profit, the 10% chance of breaking even, and the 30% chance of losing money. We're going to put that into our calculators, and we're going to find that 60% of $800,000 is $480,000 plus 0, and then we put 30% of $1 million in, and we're going to get a negative, I'm going to change that to a subtraction sign, a negative $300,000. When I add those together, I get an expected value of $180,000 profit to their annual revenue. So that's our expected value, is $180,000. Okay, we can do this not just with financial, but we can also do it with, in this case, test-taking strategies. Now, Maria is taking a multiple choice exam in which there are 5 possible answers for each question. The instructions indicate that she will be awarded 2 points for each correct response. She's going to lose a half a point for each incorrect response, and no points will be added or subtracted for answers that are left blank. If Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess at an answer? We're going to start there. So again, we're going to go back to our highlighters and we're going to highlight some important information. She's going to gain 2 points for each correct response, so that's going to be a positive. She's going to lose a half a point for each incorrect response, so that's going to come away from her score. That will be a negative. And no points will be added or subtracted for answers that are left blank. Now, there's 5 potential answers for each question. So I'm going to have to figure out the probability for each one of these. Unlike the problem before where they already gave us the probability, we're going to have to figure this one out. So the probability that she answers correctly is equal to 1 out of 5 chances. So she does not know the answer and she just guesses. The probability of her guessing correctly is 1 out of 5. Now, the probability that she answers incorrectly is 4 out of 5. So if the probability of her guessing correctly is 1 out of 5, the other 4 would be the wrong answers. So that would be 4 out of 5 chances that it's incorrect. And then the probability with her not answering at all, that would be 0. Right? So the probability of no answer, if she doesn't choose anything, then that's 0 out of 5. She's not choosing any of the 5 answers. So that's a 0. So our expected value, E, is going to equal the probability times the number of points that she's going to gain for getting that correct. So 1 out of 5, if I put 1 divided by 5 in my calculator, 1 divided by 5 is 0.2. I can either put 1 out of 5 times 2 points plus 4 out of 5 for negative 1/2 point, because losing a point would be a negative. And then 0 out of 5 gives you 0 points. So not choosing anything gives you 0 points. So let's highlight those. So this comes from my 2-point gain. This product would be a 1/2 point loss, hence the negative, and no points awarded, 0. So like I said, when I was starting this, 1/5 is the same thing as 0.2. So I can say 0.2 times 2. 4/5 is 0.8. So I could say 0.8 times negative 1/2 is negative 0.5. And then plus 0. I'm going to put this into my calculator. And I put 0.2 times 2 in there. And I get 0.4. And then I'm going to have a positive times a negative is a negative. 0.8 times 0.5 is 0.4. If I add those two together, I get a 0. So the expected value, is it to her advantage or disadvantage to guess at an answer? The answer is no. There's neither a gain nor loss over time. So the answer is no advantage or disadvantage. So no advantage or disadvantage. Now, what happens if she can eliminate one of the possible choices and no longer out of 5 this is now going to be out of 4. So that's what we're going to do next. And I'm going to need a little bit more room here. I'm going to apologize for that. I'm going to make this right here and here. And I'm going to say B is right over here. So if she can eliminate one of the possible choices, how does that change her guess of correct? So her guess is 1 out of 5 is going to be 1 out of 4. And guessing incorrectly, she rules out one of the answers. The remaining incorrect answers would be 3 out of the 4 remaining. So guessing incorrect would be 3 out of 4. And of course, we already know that if she doesn't answer, it's going to be a 0. So I'm not going to worry about that this time because I've just done this problem. So I understand that that third piece is just going to be a 0 if she doesn't answer, because no points are going to be added for answers that are left blank. So the expected value is going to be 1 out of 4 times 2 points plus 3 out of 4 for negative 1/2 points. And when I multiply that together, I'm going to get 0.25 times 2, or 1/4 times 2, which is 0.5. And here we will get a negative 3/8. So 3 divided by 8 is going to be 0.375. 0.5 minus 0.375 is going to equal 0.125. And sometimes your answer is going to be a fraction. So I'm going to convert that to a fraction, and I get 1 out of 8. So that's the probability. That's the expected value based on the probabilities. So 1/8 of a point will be gained because it's a positive. So 1/8 point will be gained over time, each time she guesses. Now you can't gain a point, but when you add them all up on average, that's what she can assume. So if she can rule out one of the questions or one of the answers to the question and reduce those choices from 5 to 4, 1/8 of a point will be gained each time she guesses. And that's just based on the expected value. Okay, in the next video, we're going to do a couple more examples, and then we'll move on to fair price.